Okay, so what we need to do is we're asked to draw a scatter plot. I'm going to do it on the calculator. So the first thing we want to do on our calculator is, I generally recommend when you're using your calculator to start by pressing on, create a new document over here. Don't use the scratch pad. Say no to saving the previous, and always start by adding a calculator. You're always going to want to do some sort of calculations. Next up, we're going to add, in order to enter this table of data, control, add page, and then we're going to add a list or spreadsheet. Start off by naming the top two here at the top. Once you've named this, it's going to stay in the calculator's memory until you press on and start a new document again. So be careful if you call it X and Y and you're using multiple X's and Y's. It'll cause you some confusion, but you can have these as your X variables and have these as your Y variables, and then type the data in. Take a minute just to type your data in now as you see it. This is the area where you make most mistakes, is just typing these in. Especially when there's two in a row, like the two 750s. There's 10 camels, it says in the question, so make sure you end on row 10, otherwise you've missed a row. Typically, if you're missing anything, it is the fact that two get repeated one after the other. The most common error when entering data like this and you're doing your bivariate data, your statistics, is not to press enter here on this last one. So you'll get a syntax error message from some procedure that you do next and say there's something wrong. And typically it's because you stop writing there at that point and move over to calculate and you haven't pressed enter. Very, very common error. Good chance somebody will do that in the room today. So this question asks us to draw a scatter plot. So we need to add another page. Sorry, let me just see this. Has everybody typed in? Yes, we all typed in. Have you already drawn your scatter plot? Well, aren't you? What was your IM2 teacher like? He must have been amazing.
John.
Okay.
So you're in a silly mood today.
I am. I'm trying to make the new people feel welcome. I am. And also, it's the beginning of the week. You know, by the end of the week, I'm like, oh, okay, just do some bloody work. Okay. So here, I press Control, Add Page, and chose Data and Statistics, number 5. You can just press 5 on the keyboard. So, what we do now is we click here at the bottom, Add Variable, and you press X. You click on the left-hand side, Add Variable, and you click Y. And it will do a scatter plot. Okay, so describe, comment on the relationship.
Sure.
Explain to the person next to you, what is the description of this relationship? While I come around and look at the screens.
Wow.
Yes. Remember I said somebody would make the mistake of not pressing enter today? Name of the one. Okay, so what type of relationship do we have? Let's hear it from one of the new people. Let's hear it from one of the new people. Yes. All right, can we have quiet? Chatties.
To check with the calculator, we have to like a linear regression, but just from seeing it, you can see that it has a strong positive correlation. So.
Okay, so your final answer, please.
As much as I don't as well.
Can I have your final answer, please?
As the highest camera uses shows the way.
You're too verbose. You gave way too much.
A positive, medium, moderate.
Sir, please. Strong positive.
It's not that strong. It's not very
It's strong. Moderate.
It's not perfect.
Okay, so always answer something like this. A strong positive correlation. Use the adjective strong, weak, or moderate first, and then positive comes next. One of the hardest things to learn in English is which way around to put those. I had no idea how to come up with which one comes first, but the English teachers can maybe help you with that. But it is strong, weak, and moderate, positive, negative, no correlation, in that order.
Sorry, I would say strong.
Is there like a preference?
Let's. Sorry, go on, Cass.
Is there like a preference for like the IB examiner? Like, do they want it to be strong positive or positive strong?
Definitely strong positive, because if you say positive strong, you'll sound stupid. We won't know why it sounds stupid. We just know it's the wrong way around. It's just the way that you say it in English.
Thank you.
Okay. Should we check whether it's moderate or strong? I'll just do a quick check.
It's okay, I checked at 0.9. Yeah, 0.95.
0.95? That's very strong. That's very strong. Yeah. So you need to get used to how. Let's do. I can't quite draw it on here. So if you sort of imagine that X, there is nothing in the other two quadrants. If I draw the X like this through that point, and it's very close to a line, that one. We do have an exercise on AISL today where you have to estimate how strong the correlation is. So you get a little bit more used to it. Okay. Dependent and independent variables. Dependent and independent. This is something that relates more to science than to math. And it can be really difficult. Typically with the IB questions, when they give you, in the IB, they almost always give a table looking like this, going across the page. The top one is always to be the X, the second one is always to be the Y. In math, we don't really sort of test you too much on that one, but in science, sometimes it's like, which is the independent variable, which is the dependent variable. So to discuss with the person next to you, which axis, the x-axis should always be the independent variable. The x-axis should always be the independent. Which of these two is the correct scatter plot? Discuss with the person next to you and explain why. Discuss with the person next to you now. Begin talking. All right, so does umbrella sales cause the rain to fall?
No.
Does rain falling cause umbrella sales?
Yes.
Yes. So rainfall is obviously independent. The rain can still fall without the invention of the umbrella. This is the independent variable. Correlation, however, one of the important things in correlation is it does not always imply causation. So if two variables correlate, there could be for three reasons. One causes the other. There is a causal connection. Maybe both of the variables are caused by a third variable which is not seen. That's on. So either one variable causes the other, such as quite possibly rainfall. We never say actually causes it. We just say there's probable evidence to assume it causes. Statistics like this is never definite. It's always, it might be this. The data says that this is implied. It never actually declares it. So we can say that one variable causes the other, or there is a plausible reason to suggest that one causes the other. There is a causal connection, a causal causation, which is where one is caused by a third, or there's no causation. Often we have to spot that in our diagram. So have a go at this question now and decide where. So draw the scatter plot, describe the correlation, and identify one reason whether or not you think there's a causation or not. 5 minutes for this one.
I did get some good ones. It's not good. The table shows
I do. And then to use the student for 12.
this is strong.
Model.
Let me see. No, it could be. Yeah, it's strong. It was 0.4.
Okay, one more minute.
How do you know? Why do you know what bounds are here? When did you get this? In my course. I didn't do this.
You did the by hand drawing through the midpoint as well already.
Yes. Describe the correlation. What do you mean? No, wait, what do you mean? No, it's trying the mean of the x and mean of the y. Plotting on the graph and then.
Line of best fit if you're drawing it by hand. Line of best fit should go through the mean line. They don't ask that question anymore.
We have on our second test.
It's all math studies question. They used to ask it every time on math studies, everything.
Honestly, they should.
That's why they don't. That's why they did, and that's why they don't. All right. So describe the correlation between the two variables. Roger. Strong positive correlation. Is there, state with a reason whether you think that one variable causes the other or not? Does one variable cause the other?
I think.
If we have two more family members, will we get an extra pet?
No.
It doesn't cause it. It doesn't cause it. There's a correlation here, but it's not going to make it happen. It's not going to make it happen. All right, let's have a go at this one.
No, dog, that's so cool. I be sure
Okay, one more minute. Okay, so what type of correlation do we have here in the scatter plot? Strong positive. Bit of a pattern to this. Do you think there's a causation? Will opening schools create restaurants? No, this is not. Is there a possible reason why the number of both are why they are correlated?
Because that's an area where people live.
This one would be for me. I think this is a casual causation. I think there is a casual causation behind this one. We don't have any evidence for it, but I would assume that there's something else happening here. What would the third variable be? Population. So you have population growth happening here on this one, probably. So over this 40-year period, maybe this town has grown considerably. It's looking like it's almost doubled in size, not quite. By looking at how these values are almost doubling, we could say that the population has almost doubled over that period. And that seems to be normal as well, with our understanding of the world around us, particularly here in Dubai. I think it would go much quicker. All right, let's have a go at this one.
Negative.
No.
So are they always going to be in order of X then Y?
Yeah, typically I haven't seen them mess with that ever.
So when are we going to get this back?
Today.
So I did so horrible.
The curve was so big.
Was the curve big?
I don't understand how you
The
got
curve, the IB curve is standard. We have a standard curve for every test.
This is
So 80%
I don't understand how you get that.
gets curved to our mark.
Also, like, you got your decision.
No,
What is I get?
it means you got overhead.
How is it that? So can you put it back to the waiting?
Sorry.
Can you put it back
Well, I don't know what you are.
to
It's simple. This class is so easy.
The semester exam wasn't included in I would say very but it's certainly not going to go negative. Yeah. Not negative. Right, yeah, sorry, the number of days I'm going to. And then it would all right, let's have a look. No, there's still a few more pages of theory. Okay, so we're drawing our scatter plot. Describe the correlation between the two variables. Andrea, what is the correlation? A strong negative correlation. State whether one variable causes the other. Do we think one variable causes the other? Sorry?
The time.
So if you leave
The temperature. The time and days cause the darkness.
it's not a time of days, it's the number of days.
I know the time and days.
So the temperature, the hotter it gets, the quicker the milk turns, the cream turns sour. Does that seem like the temperature could cause the cream to sour? Yes, definitely. It's going to increase the reaction rate up to about 36 degrees is where it's going to hit its maximum. After that, it's just, well, depending on how high we go. If you go high enough over about 65, it's going to cause it to, it's going to kill the bacteria, do some other reaction to it, probably cause it to separate. All right, so next up we're going to look at Pearson's product moment correlation coefficient, often known as correlation coefficient. And we can sort of quantify this. A lot of you are already familiar with this. So here we see a weak positive linear correlation of 0.3. Doesn't look like there's much correlation there. But notice when I do this, you can see it is mostly here and here in these two. We can see it. Strong positive linear correlation, 0.9. They're still spread out a bit. And a moderate negative correlation. So we have certain ways of quantifying this. So if the absolute value is between 0 and 0.25, we call it very weak. If it's between 0.25 and 0.75, 0.25 and 0.5, we call it weak. From 0.5 to 0.75, this is moderate. Above 0.75 is strong. Above 0.75. Yeah, above 0.9 would be very strong. So above 0.9 would be very strong. Okay, so how many did we do? This is our last slide. Okay, so let's have a go at calculating that. So enter the data here for this last set. We've got math and biology. Okay, so what type of correlation do we see in this scatter plot? Strong? Positive? Correlation. So the last thing to do is to calculate the correlation coefficient. I recommend always doing it. You can do it in three places. You can do it on the statistics page, you can do it on the spreadsheet page, you can do it here on the calculator page. I recommend doing it here on the calculator page. We press menu 6, 1, 3 for linear regression. You choose your X list here, you choose your Y list there, like this. Notice it's going to store the here. It's going to store the regression equation in the first available slot. So I don't have any graphs in at the moment, so it's going to store it in F1. That's useful to us. It looks like this. So we want to have it in 3 significant figures. So document settings, change it into float 3. Press enter, and it will recalculate it into 3 significant figures for you. So we see R, it's the bottom one, not the constant of determination. The correlation coefficient is R, 0.864. So R is equal to 0.864, which implies strong positive correlation, linear correlation. Okay, when you do your IAs at the end of the year, a lot of people do an IA with a correlation. When you do your IAs, one of the first things when you've collected your data, if you have bivariate data and you collect it, the important stage is to start by doing a scatter plot. You do a scatter plot first before finding the line of best fit or anything. The purpose of the scatter plot is to look at the data and say, that looks like it's in a linear pattern. So the purpose of the scatter plot is to identify whether it is in a linear pattern or not. It's an assumption. So this one here, we did linear regression. Could it be another type of function?
Exponential.
Exponential. If you look at that curve, that also looks like it might be an exponential curve. So the purpose of the scatter plot is to sort of say, well, this one looks like an exponential curve or a linear. I'll consider both. Or in this particular situation, the number of days is not going to go negative. So the hotter and hotter it gets, it's not going to start having negative days. So linear doesn't make sense on that one. It's much more likely to come down to a horizontal asymptote of y equals 0, and it's much more likely to be exponential. Much more. And even going backwards, if we go upwards here and the temperature goes into negative degrees, it's going to basically freeze it and last for months and months. So that would start to make sense. It would start to make sense that it would be exponential on that one. So look at your scatter plots and decide whether it's what type it's going to be. So what we're going to do now is I'd like you to work with the IXLs JJ3 and JJ4. This I'm going to assess and stick it into the Power School. It's already on the Googly Classroom. I'm covering a bunch of chapters from the textbook. So I'd like you to have a look over some of the material in this and see which bits and pieces are covered and do a sample of questions, but you can't do all of the questions from all of these sections. So do a sample of questions from those sections. Yes?
Is this, like, when you put it in this number three, is it?
I don't know. It's semester 1 now. I forget when this week is semester 1.
Can you please, like, I beg you, I'll do it right now. I'll do it right now.
It's likely to make little difference.
Yes, please, I need one.
Let me take attendance.
Yeah, I need one.